So how do I go about solving linear inequalities? So we treat a linear inequality like an equation until it comes to our solution set, right? We need to write the solution set in interval notation. What we're going to do first is we're going to simplify the algebraic expression on each side. We have to use the addition property to collect all like terms, right? We want our constants on one side and our variable terms on the other. We need to isolate the variable just like when we're working with an equation and solve. Friendly reminder that when you multiply by a -1 or you divide by a -1, when it's working with inequalities, you have to flip the sign. So if I had -7x is greater than or equal to 14, and I wanted to isolate my variable, if I divide by a negative, this becomes x is less than or equal to -2. See, I flipped the sign. Next, you want to express the set in interval notation. I find it really helpful to graph your solution on a number line, even if you just sketch like the world's fastest number line. Like, make sure you got 0. Here's -2. Okay, my endpoint is included. You might want to use a different color. My endpoint is included and x is less than or equal to -2, so it's everything over here. This kind of helps me quickly visualize how to write that in interval notation. Now I see, okay, my solution is from -infinity all the way to 2, and my endpoint's included, so it gets a square bracket. So let's work through another example. I'm going to go ahead and divide both sides by -4. That means I have x is less than or equal to, see I flip my sign, -7. I gave you a blank number line, so label it how you want. I've got -6 here, -7, -8. You don't have to label everything. If I have x is less than or equal to -7, that means -7 is an endpoint. And I'm going to go ahead and shade everything to the left because it's x is less than or equal to. This means now I can write this in interval notation from -infinity all the way to -7, and -7 gets a bracket because my endpoint is included because it's less than or equal to, one or the other. Next example, I have x minus 6 is less than -14. I add 6 to both sides. I get x is less than -8. So I don't know why I wrote infinity. I meant 8, I promise. -8. So I'm going to go ahead and -8, -7, -9. -8 is not included because it's x is less than 8. It's less than, so I'm going to shade everything to the left. So interval notation for this problem would be -infinity all the way to -8. And that gets a parenthesis because the endpoint is not included in the solution. Let's do one more, a little bit more complicated example where I need to distribute. So I've got -3 times x plus 4 plus 2 is greater than or equal to 7 minus x. So I'm going to distribute that -3. Then I need to combine like terms. I've got -12 plus 2, so I have -3x minus 10. It's greater than 7 minus x. I want to isolate my variables, so I'm going to add 3x to both sides. So I have -10 is greater than or equal to 7 plus 2x. I subtract 7 from both sides. -17 is greater than or equal to 2x. Next, I divide both sides by 2. -17 halves is greater than or equal to x. So -17 halves, that's like -8.5. If we were going to write it as a mixed number. So here I have -8, -9, -8.5 is right there. This is -17 halves. If I'm going to graph this real quick, my endpoint is included because it's less than or equal to. And I have x is less than -17 halves, so it's going to go this way. So my interval notation would be from -infinity to -17 halves with the endpoint included, so it gets a square bracket. Now here are a couple inequalities with unusual solution sets. So if I have x is greater than x plus 1, this has no solutions, right? Because no number is greater than itself plus 1. So for example, if I had 4 is greater than, let's say x equals 4. 4 is greater than 4 plus 1. Well, I have 4 is greater than 5. If I have negative 4, we'll let x be negative 4 now. If I have negative 4 is greater than negative 4 plus 1, negative 4 is greater than negative 3, that's a lie, right? It's a false statement. So this has no solutions because it will never be true. Let's take a look at why this equation right here has infinitely many solutions. So if I have 3 times x plus 1 is greater than 2x plus 1 plus x, I distribute, I combine like terms, subtract 3x from both sides, I get 3 is greater than or equal to 1. Well, this is always going to be a true statement, no matter what I plug in for x. So because it's always going to be a true statement, it has infinitely many solutions.